of our EC2 instance. So then some basics about scaling, like what exactly vertical scaling and what exactly horizontal scaling is. All right. So here in today's session, we are going to start with load balancer concept. Okay. So, but before that, any questions on our previous session?
Yeah, Avinash. Hi, Avinash. Very good morning.
Hey,
Yeah,
good
so
morning.
hypervisor. Yeah, so it's a bit confusing. Anyways, so what is the difference between hypervisor and ESXi host? I heard about ESXi host also.
ESXi is a hypervisor.
Oh, okay.
Yeah,
ESXi.
basically, hypervisor is a technology name.
Okay.
So we have some standard hypervisors in market. Okay, for example, VMware, they developed ESXi.
Oh,
Similar way, Microsoft developed their own hypervisor. So that is called Hyper-V.
okay, okay.
And AWS used an open source so far. That hypervisor name is Zen Hypervisor. And later, AWS developed their own hypervisor called Nitro Hypervisor. So basically, hypervisor is a mechanism which convert in simple physical resources to virtual resource. So you need some CPUs, memory, hard disk for your instance or VM you are going to run, right? So the
Yeah.
hypervisor runs on top of hardware. It will take the resource from the hardware and it will give to our operating system. That is hypervisor job. So ESXi is one of the hypervisor.
Okay.
And it's widely used one compared in enterprise level environments. It's a widely used one.
Okay.
Yeah.
Yeah. And one more thing, Avinash. So what
Yeah.
is the difference between this bare metal hypervisor and the containers?
The bare metal hypervisor and container is different concept. I'll tell you. Basically, we have a session on that, but I'll give quick overview. So virtualization versus containerization. So in this virtualization versus containerization, you observe here, as I told you, we are going to have a physical resource. Forget about container now. We have physical resource. On top of that, whatever application we selected, like a ESXi, Hyper-V, Zen Hypervisor,
Correct.
we are selecting it. So then you are running your server, right? So this is like you are taking a Windows operating system or Linux operating system, you deployed your application and you are delivering it. Fine. So then after, to deliver that application, you are using some binaries and libraries. Okay. So that is actually dependent on guest operating system. So sometimes you might hear about this. Okay, this application is working fine in my laptop, but it is not working in another laptop. Right. So why? Because I have required dependencies, all the things. So setup is as per that application requirement we configured. So fine, it is working here. Then you have moved that to different server. So there it is not working as expected. So the reason is the operating system. Is it because of hardware? Both are running in same hardware. So no problem with the hardware. It's because of OS level settings. Okay. And also you observe these operating system is taking lot of resources. Just to run a plain operating system, you need to have minimum, if it is a Linux, you need to have minimum 2 GB RAM. And around 2 GB or 3 GB, OS itself will take that. If it is a Windows machine, you require minimum 30 GB. And it is going to take minimum 4 GB RAM. That is a minimum requirement to install or run any operating system. Forget about the application. To run operating system itself, we need to have the resources. So then later we got an idea. Okay, why can't we eliminate these operating systems? Why can't we directly share that a common engine, a common machine to all these operating systems? So these operating system layer is eliminated. First advantage is resource wastage is reduced. So then second advantage, so it is using a container engine. So that will take care about libraries, binaries, all the dependencies. Okay. So now whatever application you are running, if it is working here, it works in your machine also. All you need to have is same container engine you need to have. So that is the advantage with containers nowadays. Okay, it just containers will come in interview, not in real environment. In real environment, still like it's a very new technology. In
Oh,
2016, I believe it people came to know about it and they're trying this, they are exploring it. Okay, yeah,
okay. Okay, all right. Thank you.
yeah. Again, we will discuss about this. We have a service called ECS. We will discuss this.
Okay.
Sir,
Yes, please.
you said like do one task like create one instance in Mumbai episode and one another one is Northern Virginia. While creating in Northern Virginia, I was like not able to launch the instance in particular
Okay. First thing, did I really ask you to launch any instance in Northern Virginia? For which task?
You are given regarding copy the snapshot to the desired region.
I have not asked you to perform that. Where is the task? I've never asked you to copy any snapshot to any other region. Why? Because it involved with cost. I've not asked you to do that. So I ask you to create a snapshot in same region and try to launch in same region. These are the possible scenarios, but these are not the tasks, right?
Okay.
These all are the possible scenarios. So here is a task. Okay. So do not copy anything from one region to another region. It will incur some cost. Okay. Right. So right. So here in today's session, we are going to discuss about load balancers. So the name only telling us it's a load balancer. In general, is this load balancer is a new concept? Don't we have this concept earlier? We have. This load balancer is not at all a new concept. It's there from so long time. Okay. So the mechanism behind this load balancer, right? If one guy is not able to perform an activity, what we will do? We will call for some help, right? We'll definitely call for some help. So that another guy also will try to do the same task you are doing, same activity you are doing. In olden days, for example, that chariots and all, it's very heavy. Okay. So if you want to pull that, so one guy is not enough, right? Everyone is not Bahubali. Right. So the multiple members are going to pull that. So then we can achieve it. Not only one guy. Okay. So similar way, you have a server that is delivering a web page. Fine, it is delivering some requests, but it is not able to handle all the requests. As it is not able to handle all the requests, as the first thing, what you will do? You can go and add some resources, add some CPU, add some memory. So that is a vertical scaling. Okay, you have added some more resources. You have added one more, you have increased to the maximum available one in AWS. Still, you're getting millions of requests per second. Then what to do? And also, there is a one disadvantage whenever we are going with the vertical scaling. The disadvantage is if you are completely depending on only one EC2 instance to deliver your application, if something happened to the EC2 instance, your entire application is down, right? So that is also, so we always try to distribute our application across multiple resources. Whenever you're distributing across multiple resources, if something happened to one of the server, okay, still another healthy server is there that will take the load. Okay, for high availability purpose, for fault tolerant purposes, we can depend on this load balancer concept. Earlier also we have load balancers. Okay, but it is a physical device. It's a physical device. Whatever physical servers you have, you need to add those physical servers to that load balancer, the physical device. That load balancer will have a domain name or a public IP address. Every request comes to that load balancer. In simple, You just Google this, how load balancer works. How load balancer works, just go to images. You see this image. So those are the application clients. Different customers is trying to access my application. Okay, all the traffic coming to load balancer. Whether it is a software or hardware, doesn't matter for us. But all the client requests are coming to one load balancer. That load balancer is distributing the data. So not only that, you take any image, the same mechanism. See, whether it is from computer, tab or mobile, over the internet, all the requests is coming for our servers. You see here, we have multiple servers to deliver our application. And also one of the server is not healthy. It is not healthy, but will that affect this end customer? No. All the traffic will go to this load balancer. This load balancer will take care which one is healthy, to which one we want to route the traffic. So then this load balancer guy will keep on performing health check. If this is not healthy, it won't send traffic. Okay, we need to have at least one healthy resource to deliver all the requests. So this is a load balancer concept. In general, in AWS, whatever the instances we are going to launch. Okay, so you're trying to deliver your application by using multiple instances. Every instance is going to get a public IP address. Okay, so now how we can give that public IP address to end customer? If it is 10 servers, are you going to distribute the 10 IP address to all the end customers? It is a bit difficult to manage for us and for them also. So now in this scenario, whenever you're depending on this load balancer concept, you simply give the load balancer name to customer, or you map a domain name. You purchase a domain name. Okay, so you map the domain name to load balancer and give to end customer. So he really no need to worry how many healthy servers they have, how many unhealthy servers they have. All they need to have that domain name and one healthy server in backend, the request is going to deliver. Okay, so this is the general load balancer concept. We have total 4 load balancers in AWS. One is outdated. That is a classic load balancer. Classic load balancer is deprecated, outdated. Still, I'll explain. I'll take a minute and I'll explain. Okay, so the widely used ones are application load balancer and network load balancer. We even call it as ALB and NLB. Application elastic load balancer. Either you can call it as application elastic load balancer or application load balancer. Okay, so both are technically same. ALB is an application load balancer. NLB, network load balancer. Both do the same work. Both do the same work, but the supported protocols are different. What protocol it supports, at what layer the routing is going to happen, that is different. If it is a application load balancer, it supports STTP and STTPS protocol. If it is a application load balancer, it supports STTP and STTPS protocol. STTP stands for Hypertext Transfer Protocol. That is STTP. STTPS means secure over HTTP or Hypertext Transfer Protocol over secure. So we need to add SSL or TLS certificate to use this HTTPS. Okay. So that is an application load balancer supported one. We have network load balancer, right? This network load balancer supports TCP, UDP, TLS protocols. These also protocols. Okay. So these also protocols. Whatever application your development team is developing, if that application is running with this given protocol, okay, so you need to go with the network load balancer. For example, your application is developed by HTTP and you created network load balancer, it won't work. You cannot add resources. You cannot add resources. So the primary thing here is, what is the factor to choose the load balancer? The factor is supported protocol. The first question you need to ask, okay, if you got any request to create any load balancer, the first question should be, okay, on what protocol your application is going to work? The communication is going to happen. So they will tell you one protocol, then you need to choose. If they tell wrong one, that is their problem. Sometimes it happens. I have a message also. I'll show you that in some time. Okay, so this is the primary thing. And you know TCP/IP or UDP layers, 7 layers, APST, NDP, computer networks in BTech. If you're a JIT student, whether you got the question or not in exam, okay, you can draw that and you can write and you will get marks. And that's what I used to do. Right. So application layer, presentation layer, session layer, transport layer, network layer, data link layer, physical layer. Right. So this application load balancer is a layer 7 load balancer. Okay. This network load balancer is a layer 4 load balancer. Just remember this. You don't need to worry. No one is going to ask you. So the why it is net level layer 7, why it is layer 4? The reason is simple. At that layer, the data routing will happen. At that layer, data routing will happen. So application load balancer, okay, is a layer 7. Network load balancer is a layer 4 load balancer. Among that 7 layers, at that layer stage, the data routing will happen. Okay. So your traffic should go to server 1 and server 2. In which level they decide? Okay, if it is an application load balancer, at level 7, at layer 7, it decides. If it is a network, at layer 4, it decides. That is a reason behind we call this as a layer 7 and layer 4. And it is an interview question. Okay. So now, first what I'm going to do here is, I'm going to launch 2 EC2 instances. Okay, I launch one EC2 instance in AP South 1A, another instance in AP South 1B. There is a meaning for this. For example, see, you have an application, you are designing an application and you are trying to deliver it. Fine. So if you place both servers in AP South 1A only, what happens? Sometimes something may happen to their AWS data centers. For example, due to some technical issues, entire AP South 1A is down. Your application is delivering with 2 servers. And both the servers you have launched only in AP South 1A. And due to technical issues, that entire availability zone is down. Your servers also will down, right? Your application also down, right? Okay. So to not get into the issue, AWS recommend us to spread our resources across multiple availability zones. So you place one server in AP South 1A, another server in AP South 1B. If something happened to AP South 1A, still 1B is up and running, right? You remember, every availability zone is independent. It is isolated from another availability zone failures. If a failure happen, only AP South 1A will get effect, not AP South 1B. It won't get effect. Okay, so that is the reason I'm going to launch one in AP South 1A, another one is in AP South 1B. Okay, why I need to follow? I want to launch 2 in AP South 1A. Yeah, you can launch it. There is no harm in that. Okay, there is no harm. It won't give you any error, but it is recommended to go with the 2. So I'm launching one in 1A, another one is in 1B. So then I'm going to add a load balancer. Okay, so then both the instances I'm going to add on top of this load balancer. Whenever any end customer is trying to access, he is going to hit the load balancer, and load balancer will get the web pages from our EC2 instances and it will deliver. Okay, so if you take it in diagrammatical manner, this is a diagram. Okay, this is EC2 instance 1. It is in AP South 1A. This is in AP South 1B. And I'm going to place an elastic load balancer. Okay, so both the instances, is now going to add to this load balancer. Okay. So now end customer, whenever this guy is trying to access, his request will come to this load balancer. Now what this load balancer will do, it will continuously perform health check. What is health check? What is health check? Simple. It will go and verify whether that instance is healthy or not. Okay. How it is going to verify? It will ping. You know what exactly ping means? What is a ping? For example, I can take this terminal and I'm going to ping google.com. What exactly happening now when I gave ping google.com?
It is checking whether the remote, the target server is available or not.
Yeah, it is going and checking whether the target server is available or not. So I'm trying to here ping google.com. It will go and check whether google.com is healthy or not. So if I want to verify that my network also should healthy. If I don't have internet, can I ping Google? So not only the target or remote server, from our local network to remote server, the entire connectivity is healthy or not. Okay. So the entire path, how much time it is taking to deliver the request. You see here, these values, 17 milliseconds, 21 milliseconds. Technically, these are the latencies. Latency is nothing but how much time it is taking to get a response from that server. Okay. So similar way, this load balancer will go and ping our EC2 instances. For pinging, they are going to use the default port number 80. So load balancer will go and ping on port number 80, and we can give a specific path like a index.html, status.html, we can give it. Now, okay, fine, it is going and pinging, and now this instance need to give response, right? The logic is very simple, guys. So I'm asking you, are you healthy? Give me an answer. Are you healthy?
Yes.
So you're taking some time, right? So, and if I ask now, if you tell after 2 minutes, yes, will I consider it? No, right? So when I'm asking something, you need to respond to me back in a specific duration. You need to respond back within 2 seconds. Okay. So the 2 minutes is a response time. Okay. Now, similar way, this load balancer going and asking this EC2 instance, hey, are you healthy? Now, this EC2 instance need to give response within 2 seconds. Okay. That is a response time. Okay. That is a request response. Whenever a request goes, how quickly we are expecting response. Fine. Now I asked you, you gave response. Again, after some time, I'll get a doubt again. Are you healthy again? I'm going to ask you again, right? So you're going to give response again. I'll wait for some more time and I'm going to ask you. Why? Because that is what my job is. If you are healthy, then only I'm going to teach you. If you're not healthy or if you're not active, I'm not going to teach you, right? Okay. Similar way, duration between the health checks. Now, I asked you, okay, I'm going to wait for 5 seconds or 10 seconds before performing another health check. Okay, I'm performing another health check here. It happened. Again, I'm going to wait 5 more seconds. I'm going to perform. So, how frequently this load balancer is going to check health status of our load EC2 instance? That technically we call it as a healthy threshold. Okay, the interval. Okay, interval is nothing but duration between health check to health check. For every 5 seconds, for every 20 seconds, for every 30 seconds, how frequently the health check need to happen. So that is a health check interval. Fine. Okay, are you going to consider only one health check to declare that instance as a healthy? No, right? Sometimes due to some issues, one health check may failure happen. Because of one health check, you are not going to declare it as unhealthy, right? Or healthy, right? So you are going to consider 2 or 3 health checks to declare that as a healthy or unhealthy. The logic is simple, guys. If 3 continuous health checks are success, then only load balancer treat that instance as a healthy. Otherwise, it will treat that as a failure. Okay. So similar way, unhealthy health checks also. If the health check is unhealthy, only 1 is not sufficient to stop sending traffic. We are going to take, okay, at least 3 or 4 or 5, you can configure till 10. Okay, if 3 consecutive health checks are failure, okay, the load balancer will stop sending request. That we can configure. So these are the factors that load balancer uses to check status of our EC2 instance. Okay, so clear? Any questions on this? Is it clear? This is our EC2 instance. I'm just repeating this. Here is my load balancer. Now, this load balancer will go and check this EC2 instance health status. This need to give response within 2 seconds. If it won't respond within 2 seconds, that health check is failed. And when the next health check is going to happen? After 5 seconds. I'm taking all least values. You can take 30 seconds also. 5 seconds is the least value. Again, after 5 seconds, it will go and perform health check. And this need to respond back within 2 seconds. Again, it will wait for 5 more seconds. Then it will perform. Whether this EC2 instance is healthy or unhealthy doesn't matter. Load balancer will perform health check for unhealthy instance also. Why? Because after some time it may become healthy, right? Whenever it becomes healthy, the load balancer will detect it and it will start sending traffic. Okay, so this is a process. Okay, so it will use a protocol called ping, Pocket Internet Gopher. Ping means it pings over port number 80. That is nothing but HTTP protocol. Okay, and we can define the path. Okay, I want to ping to index.html, or you can manually create files like a status.html and you can perform the health check. Clear with the concept? Any questions for now? All right. So I'm going to quickly launch 2 EC2 instances. I'm going to make them as a web server. So then, so you can do it, those EC2 instances as a web servers manually, or you can use user data. To save some time, I'm going to use user data. Is that okay for you guys? Launch instance. I'm calling this as 1A web server. I'm going to take Amazon Linux. I'm going to take T2 Micro, and I'm going to take my Linux KP. And as I told you, this is a 1A instance. I'm going to launch it in AP South 1A. And I prefer to create a new security group. I'll tell you why. There is a purpose for this. I'm creating a new security group. Web server SG is the name I'm giving. Web server security group. So first of all, it is a Linux instance. So port number 22 must be open. And I'm going to make it as a web server. What another port we need to open? HTTP. Go here, 80. Open HTTP. That is nothing but 80. Perfect. So I'm going to make it open for anywhere, everywhere. Okay. So then scroll down. 8 gigs is okay. And expand this advanced details. And here is a user data. Here is a user data. And I'll use a very simple user data, guys. Okay, I'll share this user data also. Okay. Or else the regular user data is there, right? Okay. This is a user data. Yum install httpd-y. Service httpd start. chk config httpd on and echo. This is a web server from, and it picks the host name of that instance. It picks the host name and it is going to write to var www.html. Okay. So you know the script, right? And what exactly this is dot host name? Okay, go to command prompt. And if you give dot dollar host name, if you gave dollar host name, you see this? What it is showing? It is showing my computer name. See, I can simply give host name command. If I gave host name, it is showing my host name, but on the terminal. Okay, but I don't want to this is a host name direct command. But if I gave echo and I'm going to take that value here, whatever the command I want to execute, I'm going to give next to dollar and price. You see, same output. The same thing is happening here. The same thing happening here. So this is a user data I'm taking here and I'm giving it here. So I can tell, okay, this web page is delivering from web server 1. Or else, if this is confusing you, so you manually log in and you create a web page. Okay, then launch instance. Now one EC2 instance is launched in 1A, AP South 1A. You see here, it's in AP South 1A. Launch another instance. I'm calling it as a 1B web server. Again, same Amazon Linux T2 Micro. I'm going to choose an existing key pair and I'm selecting it AP South 1B. And the security group, web server SG, I just created some time back, right? I'm selecting it. So then expand advanced details. I'm giving same user data here. Then click on launch instance. Now I have two EC2 instances. Both are running in two different availability zones. And if the user data executed successfully, we should get output, right? Might take some time. Yeah, you see here, this is a web page from, this is the IP address of my 1A machine. You can verify that. You see this 38.73, 38.73, that is a 1A web server. 1B web server will come with 14.151. It will take a minute or two to execute that script. Okay. Right. So let's grab the public IP address. That is a host name. That is a host name. Host name is defaultly set with this private IP addresses.
Okay.
Host name defaultly set with private IP addresses. Why? Because public IP address will change. So that's the reason it won't use public IP address. But private IP address, once it is allocated, it is going to be fixed for that entire instance lifecycle. Whether you perform start, it won't change. But public IP address will change. So that's the reason AWS don't use public IP address here. They will use private IP address. You see here, this is 14.151. Now I have two EC2 instances. Both are delivering two different web pages. Correct? And both have different IP addresses. Now, let's assume both are delivering same content, or you want to deliver both the web servers to one of the client by giving a single point of contact. So obviously we need to depend on load balancer only. I'm going to create a load balancer now. The concept is clear, right? The load balancer concept. Now I'm navigating to load balancer. Click on create load balancer. Now you see here, application load balancer, network load balancer. This is this is, if you want to use this gateway load balancer, that is for different security appliances. You need to purchase that from marketplace. So this is recently introduced. Don't worry about that. So if you scroll down, you see here, classic load balancer. It is a previous generation one. Okay. From August 15th onwards, AWS stopped supporting also. So if you got any issue and all, AWS don't respond to that issues or that security vulnerabilities and all. They don't patch it. They don't support it. So organizations really not using it from so long time. They're not really using it. But just to understand the concept, I'll take this and I'll explain you. Okay. So click on create. What is a load balancer name you want to give? I'm calling it as a my ELB or classic ELB is the name I'm giving. In what VPC? We have only one VPC so far. So go with that VPC only. Now, you want to create an internal load balancer. If you select this option, this load balancer works as intranet website. What is intranet and internet? Intranet works only within the organization. Intranet works only within the organization. If you come out from organization, you cannot access that web page or website. Okay. So this load balancer works. It will distribute the load, but you cannot test output. You cannot access outside of AWS environment. But I want to test from my local laptop. I want you guys also need to test it. So then do I need to enable this? No. If I enable this, it is going to create a internal load balancer. But I want to access from outside world. So this works only within the AWS environment if I select this option. But I want to test from outside world, I'm going to uncheck it. So then it is going to pick port number 80 and it is going to redirect the traffic to port number 80. Go with the default. Again, now if I open HTTPS, I can open it. But in next step, I need to browse the SSL certificate. You see here? Now, if I want to explain this SSL certificate, I need to explain Route 53. Then only I can explain ACM. So that's the reason we don't discuss this now. Okay, we'll come back here and we will discuss after Route 53. So go with the default option you got here called HTTP. And if you want to choose how many subnets this load balancer is going to use, select this option. Enable advanced VPC configuration. It will ask you, okay, I want to use AP South 1A. You read this. Select at least 2 subnets. The reason high availability. If you're depending on only one subnet, okay, it may goes down. So if any issues are occurred, our application will be down. So select 2 subnets at least. So I'm selecting 1A as well as 1B. If you want, you can select all the 3. There is no harm in that. Okay. Otherwise, just go with the default. Do not check it. You don't need to select anything. If you select it, select all the 2 or 3. Then click on next. Security group. I'll create a security group. I'm not using an existing one. I'll call this as a ELBSC. Remember, this elastic load balancer is not a server. This elastic load balancer is not a server to get connected to it. If it is a Windows, we need to open 3389. If it is a Linux, we need to open SSH. Similar way, can we connect to this load balancer and can we see? No, it's just a virtual appliance. If you want to access it, use IP address over the browser. So port number 80 opening for everyone is too sufficient for us. If you open additional ports, still 80 is mandatory. If you want to open additional ports, you can, but there is no meaning for it. Okay. So then click on next. So ignore this warning. Why? Because I have not opened SSL. That's the reason it is giving warning. Then click on next. Now, whatever the security checks we discussed, right? The health checks and all, that is, we need to configure here the health checks. So it is going to use HTTP protocol. It is going to ping index.html. Response timeout. When load balancer is checking health status of load balancer, how quickly how quickly instance need to respond? Within 2 seconds. I'm configuring all minimum. Interval, duration between one health check to another health check, 5 seconds. And how many health checks you are going to take to declare that instance as unhealthy? 3. How many health checks you are going to take to declare that instance as a healthy? You can take 2 or 3, anything is fine. You can even take 2 also. So these are the options we are configured here. If 2 continuous health checks are failed, AWS load balancer won't send any traffic to that EC2 instance. Okay, one small question. How much time it is going to take to declare that instance as a healthy or unhealthy now? 5 seconds.
3 seconds.
2 seconds.
3 seconds. Pardon?
21 seconds.
See, it is taking 3 health checks to declare that instance as a unhealthy as per these values also. You observe here, as per this value, it is taking 3 health checks. Now, 1 health check happened. After 5 seconds, see, it will wait for first 5 seconds and 1 health check happened. Then another health check happened. 1 more health check happened. After 5 seconds, 1 more. Now you see, if this health check is failed, 1 health check failed. This health check failed, another health check. So how much time it is taking? 5 plus 5 plus 5. It's taking 15. The logic is very simple. Interval into threshold is a time of how much time it is going to take to declare that as a. So if any instance is not responsive for 15 seconds, it will declare that as a unhealthy. Got the logic? So 15 is the answer here. Right. So now just click on next. What are all the instances you want to add to this load balancer? I want to add both. I'm selecting both. If you don't select one instance here, it won't add to load balancer. So I'm selecting both. Then click on next. You want to give any tag, you can give it review and create. This is a review screen. Click on create. The common mistakes you might perform here is, first thing, your EC2 instance must open with port number 80. Your EC2 instance must open with port number 80, not for your own IP address. Make it as of everyone. Second common mistake is you might forget to open port number 80 for your load balancer. This is second common mistake. Third mistake is you might forget to uncheck that option. If you select internal load balancer, if you're accessing from outside world, it won't work. If you select it as an internal, if you want to test output, you launch an EC2 instance, get connected to it, then only you can test it. So don't create internal load balancer. These 3 common mistakes. Instance security group port number 80 should be open for everyone. Load balancer port number 80 should be open for everyone. Do not create internal load balancer. Fourth option, select at least 2 subnets while creating load balancer. Otherwise, it won't allow you to create. 4 points to remember. Okay. So this load balancer is now created. So what is the IP of this load balancer? Generally, AWS don't give IP. AWS is going to give a DNS name. This is a DNS name. However, if you want to know IP address, you can run a command called nslookup. You give the DNS name, it will give an IP address. And backend, you can go to network interfaces and you can get the IP address. That is a different part. Keep it aside. Okay. But AWS directly don't give any IP address for our load balancer. They will give a DNS name. Grab the DNS name, give it in the browser, you will get the output. Okay, let's see that now. I'm copying it, opening a browser, pasting it. Now I'm refreshing, just observe this value. Observe that IP address, 1438, it's changing, right, continuously. So that means my load balancer, this is instance 1, This is instance 2. This is 38. This is 15, right? So now here is a load balancer. This load balancer sending one request here, another request here. One request here, another request here. Basically, it works with round robin algorithm. Nested round robin algorithm. First, second, third, fourth, fifth, sixth in this manner. Okay. So now, due to some issues, one of the EC2 instance is down. I cannot generate the issue, but I can stop instance, right? So I'm stopping one EC2 instance. I'm selecting this 14.151 instance and I'm stopping it. I'm not terminating, okay? Why? Because I want to start it again. So currently, this load balancer is showing 2 of 2 instances in service. When you go to this instance tab also, it is showing earlier both are in service. But now, as I have stopped one EC2 instance, it is stopping and this load balancer immediately detected that operation and it is showing out of service. Now, if I go here, if I give refresh, is both giving response? Only this 38 one is giving response. Only the 38 one is giving response. If I stop that one, no healthy resource. So it will give 400 error, 500 error. Server side issue. Server side issue means 500 error. You need to have at least one healthy host. Now, if you want, you can give a try. You go and you stop this also. Now, this is showing as a out of service. The reason it's in stopped state. Now I'm starting it again. Go here, start instance. Once instance is in started state, so then this will change. The status will change. It's in pending state now. Okay, it's in running state. So then what happened? This load balancer is perform the health check. It came to in service automatically. Did I perform anything? No, right? So if I go here, if I give a refresh, now you see 14 again 38. So when instance is healthy, then only load balancer will route the traffic. If an instance is down, it won't send any traffic. Clear with this concept? Any questions so far for me? Any questions for me, guys? Okay, so now, so this is about classic load balancer. But I told you that classic load balancer is bit outdated. AWS also stopped supporting this. The reason is only one application we can deliver by using this classic load balancer. Okay, but I have group of EC2 instances that delivering same application. I have another group of instances that deliver different application. So now what I want to configure is whatever traffic coming on 80. Okay, so I want to send it to group of 1 resources. Whatever traffic coming on 8080, I want to send another group of instances. Whatever traffic coming on 8888, I want to send another group of instances. So what we are doing here, instead of routing this classic load balancer, one instance, that's it. But we are creating a component called target group. In application load balancer and network load balancer, we have a concept called target group. Target group will contain targets. Again, what is a target? Target is nothing but an instance. Instead of directly sending request to instance, load balancer, sending request to instance, it sends to target group of instances. One of the instance from that group will take the request and it is going to deliver. Okay. So multiple applications we can deliver on multiple port numbers. That is the advantage. Okay. So the logic is very simple. Same load balancer, 3 set of applications, 4 set of applications we can deliver. The utilization, we are utilizing the resources more. Instead of creating one load balancer for one application, another load balancer for another application, one load balancer, it listens. It listens, okay, this guy is trying to access on 80. Then it sends group of 80 resources. Whatever request is coming on 8080, it listens. Okay, the load balancer listens. It will send to 8080 resources. Whatever request coming on 8888, it listens. It will send 8888 resources. So load balancer is now listening multiple protocols and requests. But here classic load balancer, only one, either 80 or 443. Only one works. Okay. So that's the reason, people stopped using it. All right. So now I'll create a target group. I'll add instances to the target group. Then I'll create a application load balancer. Clear with the concept theoretically? Okay. I'll show you in diagrammatical manner. In diagrammatical manner. So earlier diagram, what is that? This is an instance, this is another instance, and I have added load balancer, and these are added here, and as an end customer, we are accessing it. This is the existing one. But now, okay, I'm taking a target group. This is a target group. I'm taking another target group. I'm creating a load balancer. Within this target group, I'm going to have multiple EC2 instances. I have multiple EC2 instances, and one instance can be member of multiple target groups also. Okay. So now, whenever end customer is trying to access this load balancer, he need to define, okay, I'm trying to access 80 resources. This load balancer will listen, okay, this guy is trying to access 80 resources. So this will send it to, let's assume this is TG80. This will send it here. At the same time, another guy came and he is trying to access, okay, hey load balancer, I'm trying to access 8080 resources. Then we have configured, okay, this load balancer is listening on 8080. It is sending to different target group. Okay. The important thing is this colon 8080 colon 80 next to the load balancer URL. Next to the load balancer URL, you need to give colon 80 or 8080. This is important. Okay. Clear with this? Now, let's start with phase 1. Treat this as a phase 1. I'm taking load balancer. I'm creating a target group. I'll add both instances here and I'll associate the target group to load balancer and I'll test it. Forget about this 8080 for now. Once you guys are clear, then we will add 8080. Okay. So now, first, I'm deleting this classic load balancer. Create load balancer. And I'm selecting application load balancer. Click on create. Okay. So you see here, if you scroll down, it is asking us to select the target group. So while creating load balancer, you can create a target group. Or first you create a target group, then you configure the load balancer. I prefer the second option. Guys, please be on mute if you don't have any question. Navigate to target groups. Navigate to target groups. I have not using it. All right, click on create target group. So step 1, I'm creating a target group. Click on create target group. So this target is communicating with our instances by using instance ID. That is the first option. Second option, it will use IP address to communicate. Go with the first option. That is a commonly used one. I'll talk about remaining ones. We'll go phase by phase. What is a target group name you want to give? So I'm calling it as a app TG-80. Okay. So my protocol is HTTP port number 80. There is no change in this. Where this redirection happened? At load balancer listener level. My application always running on port number 80 only. So again, in what VPC you want to run? Default VPC. So then health check. If you want to perform health checks to index.html, you gave this. Otherwise, you just leave it to /. Anything is fine. Okay. Generally, client or developer will tell us, okay, you configure health checks to this part. That they will tell and we will configure it. Okay. So then the things we discussed, like, healthy thresholds, unhealthy thresholds, timeouts, intervals, you can go with the default option or you expand this advanced health check and you configure that. Okay. Then scroll down, click on next. What are all the instances you want to add to this target? I'm adding both. See, selecting both is not sufficient. You need to click on include as pending below. If you don't select this option, it won't add. So click on include as pending below. You see here, both the instances is now added to the target group. It's not added to load balancer yet. Then click on create target group. Now, a target group created app TG. There are two targets. Both are unused. Why? Because it is not configured to load balancer. All right. So this part is clear. I created a target group. I added both of my EC2 instance to the target group. And I am using HTTP protocol while creating the target group. Why? Because I am discussing about application load balancer that supports only HTTP and HTTPS. Now, let's go to load balancer screen, create load balancer. Smile. Okay, I can kick you out if you come up with such type of names. It is not a college, right? You're here, you're a professional, so don't add such type of names here. Even if I want, I can even find who renamed it and all. So this Zoom also have a log, right? With what name you have logged, what is the rename you have performed. Then I can stop attending the sessions also. So don't add any funny names and vulgar names in chat box. Right. Click on create. Load balancer name. Okay, I'm calling it as the application ELB. Internet facing or internal. I'm going with internet facing. Why? Because I want to access this output from outside world, right? Okay, internal means, again, as I told you, it's an intranet website. It works only within AWS environment. So go with the internet facing. Go with the internet facing. I'm going with IPv4. If your load balancer want to support IPv4 and IPv6, select dual stack. Doesn't matter for us. Okay, whether you are selecting only IPv4 or dual stack, there is no difference for us. AWS in backend, they will use IPv6. Okay, so anything is fine. It is recommended for internal load balancer, dual stack also fine for us. Then, in what VPC you want to? We have only one VPC. We will discuss VPC in our next week. Next week, we will start VPC concept. Till that time, use default VPC. And it is recommended to select at least 2 subnets or availability zones, right? If you select only AP South 1A, again, whenever you're trying to create, so it will ask you, select at least 2 subnets. So better to select 1A and 1B now. I'm selecting 2 subnets. If you want, you can even select 1C also. There is no issue at all. Now, security group. For our load balancer, I already created one. Go here, select ELB SG. Go here, Select TLB-SG. And listener and routing. Now, this load balancer is listening on port number 80. What do you want to do when traffic is coming on port number 80? I want to forward it to app TG80. So now what happened? Whatever the instance added to that app TG80, those EC2 instances will respond to the load balancer port number 80 traffic. Okay. Now, if you have multiple, you can add that here, but I have only one target group. Now, later on also we can add. One is mandatory. So, I'm opening port number 80 on my load balancer. Whoever trying to access, the request will go to app TG80. Okay. So then scroll down, leave everything to defaults, create load balancer. Just observe here, what are the options I have taken care. First step, create a target group with HTTP. Given a name, internet facing, IPv4 or dual stack doesn't matter. Select at least 2 subnets. So then select a security group. Don't go with the default security group. Whatever security group you are opening here, it must open with port number 80. Must be open, otherwise it won't deliver any output. Okay, now scroll down. Whatever target group we already created, I am adding that here. When you click here, if you are trying to find the target group and if you are not able to see the target group, that means you created target group with wrong protocol. You are creating an application load balancer. It's supposed to only HTTP. So create a target group with only HTTP, then it will display here. Then scroll down, create load balancer. All right, load balancer is now created. Okay. So if you observe this target group, earlier, what it have shown? Unused, right? That instances. When we select instances, it's shown unused here. But now you see, target registration is in progress. That means these targets is now registering to our load balancer. Once registration is completed, it will show health status as a healthy. If it is healthy or unhealthy, it will show. Okay. So now this load balancer state is provisioning. What are the ports we open in security group? For our load balancer, we have opened only port number 80. So if you want to verify what security group you have given for your load balancer, select the load balancer, scroll down, here it will show. Don't use default security group. I'm repeating this point. Default security group is a loopback security group. It's a loopback security group. Don't use it. There is a purpose for it. It opens all the traffic to itself. What is subnet? Have we discussed about it earlier? You tell me, have we discussed about it, Rajesh? No. Subnet is part of VPC that we will discuss in our next week. We haven't discussed that yet. Okay, the load balancer is in active state. And you see here, there is a DNS name for this load balancer also. And you just observe the target groups. Both instances are healthy. Now, go to a browser, give that URL, click on enter. And you see here, I'm not mentioning any port number 80, something like this. Why? Because 80 is a default. If you don't give anything, it will pick 80. So that's the reason I'm not giving :80 and all. So if I give refresh, you see here, both the instances are taking the load. This same as our classic load balancer, right? What's a different thing here? Fine, we added a component called target group and we added our EC2 instances. Till here it is same. But I told you that we can deliver multiple applications on multiple ports. So load balancer now listening. You observe this listener tab. Go to listeners tab. Whatever traffic coming to our load balancer on port number 80, it is sending to this target group. Now, quickly what I will do is, I will launch a new EC2 instance. I will launch a new EC2 instance and I will create a different target group and I'll configure to listen on different to route or forward traffic to that new target group. Okay. For that, quickly I'm launching one launch instance. I'm calling it as a 8080 web server, Amazon Linux 2, T2 Micro, My Linux KP, and I'm going to choose an existing key pair. Existing security group web server SG, and the user data. I'll use this user data. Just to make it clear, instead of this host name, this is a 8080 web page. I'll rename it. Okay. Launch instance. Now an instance is creating. Once it is created, I'll create a target group. Okay. Okay, 8080 web server. Obviously, that is a used user data only, it will work. However, you can wait a minute and you can try to test it. It's not ready yet. Okay, that is working. Fine. Now I'll create a target group. Go to target groups. Click on create target group. Okay, here is an instance. What is the target group name? App TG8080. Again, I'm not changing anything here. Go with the default options. Next step, select your 8080 web server. Then click on include as pending below. Okay, then create target group. Fine, a new target group got created. And what is the status? It is unused. Why? Because we have not added to any load balancer yet. Okay, target group is created. Now go back to your load balancer. This is my load balancer. Navigate to listener. Then click on add listener. We are asking load balancer to, hey load balancer, listen on 8080 also. Whenever you are listening any traffic on 8080, forward that request to a different target group called 8080 target group. Got it? Now, load balancer will listen on 8080. When any traffic are coming on your load balancer 8080, that will send to this target group. Okay. Right. So, but you see here, there is a little exclamatory mark here. What is the reason of this? So, you're asking load balancer to listen on 8080, but he said port open on our load balancer security group. Earlier we opened only 80, right? So, this port actually 8080 is not open. So, go to your load balancer security group, not instance security group. Even you read that error. You go here, this is a error, right? Exclamatory mark. ELBSG. So, go to that ELBSG. Go to inbound roles. Edit inbound roles. Add rule, custom TCP 8080. I'm going to open it for anywhere. Then save rules. So once you open, if you come back here, give a refresh, that should disappear. It's gone. Okay. Now Fine. If I go here, if I give refresh, only these two servers are giving responses. But how to access that 8080? Simple. Take the same URL. At last, give colon 8080. Remove slash if you have any. Then click on enter. You see this? Same load balancer on 82 servers are responding. And 8080, one more server is responding. Okay. So if you want to configure with different port and protocol, you can do that. So I will explain it again. Just see, just you guys need to understand this concept. That's why I'm creating one more. Okay. As a first step, what we need to do? Create a target group. Click on create target group. I'm going with instances as the target registration. Basically, target group use instance ID. If you want to use IP address, of course, you can do that. Okay. Whenever you have hybrid environments, we can use it. That we will discuss in our next session. Tomorrow we'll discuss about that. So go with the instance for today. Then scroll down. Target group name. AppTG 8888 is a name I'm giving now. Whatever traffic coming on 8888 on our load balancer, I want to send it to this target group. Leave everything to default. Click on next. Now, whenever any traffic is coming on 8888, I want to send it to these two instances. One instance can be member of multiple target group also. Okay. So then click on include as pending below. Then click on create target group. So new target group created successfully. And it have two instances. Both are unused now. Clear so far? Now come back to load balancer. Go to listeners. Then click on add listener. Hey load balancer, you listen on 8888. Whenever any traffic coming on 8888, you forward the traffic to a target group called AppTG 8888. Then scroll down. Click on add. Okay. Then click on view listeners. Now you see here, again we got an exclamatory mark. Why? Because our load balancer security group is not open with 8888. Go to that load balancer security group, edit inbound rules, add rules, open 8888. And I'm going to open it for everyone. Save rules. Okay. Now come back here, give a refresh. And that little exclamatory mark should disappear. It's gone now. Now grab this DNS name of our load balancer. If you give defaultly, it will pick again port number 80. Give colon 8888. Then click on enter. If I'm giving refresh, it is going to two servers. This is a listener concept. Okay. When coming to real time, I have couple of real time emails. What does 8080 mean? It's just a number. If you don't like 8080, you can take 81, 82. You can take any number. So basically 0 to 65,535 number of protocols or ports are there. Some is dedicated 22, 80, 22, 80, 443, 3389. These are dedicated. So you can take all the remaining one and you can use any. Okay. You no need to go with only 8080, 8888. These are some commonly used ones. So I picked it. Okay. If you want to go with 9999, yes, you can go with it. There is no issue with that. Okay.
But Avinash,
What is that? Load balancer. 1 second. I just want to show a couple of things.
Okay.
Yeah. Then I'll take up all your questions. So this is this one. Yeah. Just observe this. This is an email we got from one of the client. So he's saying, hi, recently you configured new application load balancer. Okay. For there is an application. So now we have a problem with request. So that requires Windows authentication. So initially he asked us to create application load balancer. So we created application load balancer and we have given it. But later he realized, seems like we need a network load balancer instead of application load balancer. And he's also stating there is a document from AWS that is misleading. So they have choose application load balancer. But actually they required a network load balancer as the authentication happened with TCP level. So which load balancer support TCP protocol? Network load balancer. But he initially asked for application load balancer. So his application is not able to communicate. So he came back again and is asking, can you please change the type of two mentioned elastic load balancers? Of course, we cannot change once it is created. So if that is not possible, recreate. That is what we did. So please advise if I'm wrong here. That is one point. Okay. So you know, this is a real email, as I mentioned. So the protocol is a matter. Choosing between application load balancer and network load balancer. Okay. So that is important. First thing. Second thing, he's asking us, okay, so earlier that health checks and everything is configured to a specific port. He's asking us to change it. So we can change it. Okay. So that is the first thing. And another, you observe this. So how many listeners we are adding? You see here, we are asking this load balancer, okay, if you got any traffic on 8127, you send it to this target group. If you are getting any traffic on 8128, you send it to this. Say, I'm not using 80808888. Different numbers I'm using here, right? So 8129, a different target group. So if you know the concept, you can create n number of the target groups and you can forward that. Okay. So this is again another real email. And this is one more. And initially, we have created a target group. So, whenever we are creating a target group, it's asking one thing, right? Okay, do you want to choose target type as a instance or IP address? So if you select instance, it uses instance ID to register. If you are using IP address, if you selected IP address, it will use instance IP address to register. Okay. So initially he asked us to choose choose target type as an instance, but later he realized he need that target type as an IP. So we cannot change once it is created. So what we did, we have recreated it and we have shared that. Okay. So that is also one more point I want to show. Some sensitive information removed from that images. All right. So for today, we have lot of additional properties for this load balancer. I'm not talking now. Let's stick to basics for today. You just got the concept. Okay. Launch multiple web servers in multiple availability zones. Configure classic elastic load balancer. That is the first task. So then create a ALB with multiple target groups. This we will talk later. Okay. So you take these two tasks for today. All right. This our network load balancer again we will discuss in our next session. All right. So just try to configure similarly how exactly I configured, right? Try to do it similarly. This is purely optional as it is a classic load balancer. My main preference or I want you to practice this application load balancer. This, if you're really interested in whatever servers you have used, right? If you want to test it, you can do that. And load balancer comes under free tier eligibility. So you are going to get 750 hours per month. So without any issues, you can practice this load balancer. But my suggestion, after practice, delete it. Okay. Yeah. Now I'm open to all your questions. So any questions for me, guys?
Yeah, nice. So what to do, like if there are multiple applications running with same port?
Multiple applications in same port, it won't work actually.